Hi, myself Dr Anirudh. I am going to explain you second experiment of analog electronics lab. In this I will explain you how to perform this experiment and what are the formula, method, everything I will say. So, the second experiment of analog electronics is analysis of bridge rectifier. Analysis of bridge rectifier. Aim of this experiment is to analyze the operation of bridge rectifier and calculate the ripple factor and efficiency. The component required in this experiment: PN junction diode, 1N4007, 200 ohm resistance, 2 capacitor, 100 microfarad and 1000 microfarad. Two digital multimeters, one used for the meter and another one for the used for the voltmeter, and CRO. CRO is cathode ray oscilloscope, and a transformer which can supply -12 to +12 peak to peak voltage, means 24 voltage. Vm is equal to 2V, means total voltage 24, peak to peak voltage is 24. One side 12 volt, another side 12 volt. So breadboard for component mounting, and second last thing is connecting wires, red and yellow wires. Red you can use for the live wire and yellow you can use for the negative terminal or ground. So before going to explain the working of this circuit, I am interested to give you a small information about the rectifier, transformer, why we are using transformer, why we are using rectifier. Power supply transmission line has AC signal, means power production in current days is in the form of AC signal. Turbine, hydrothermal power, means solar power, not solar cell, solar power, windmill, all these things, generating your alternating voltage current, AC signal. But your mobile phone, computer, digital TV, such type of equipment or home appliances you are using, those are needing DC power, DC voltage, DC current. For example, if you operate your memory on using AC signal, you cannot get a proper output, because in one signal it is stored, and for one half cycle a data can be stored, and in other half cycle the data can be erased. So one another important thing, average power, average voltage, average current for a AC signal, is 0. AC signal, for this average value for this AC signal is 0. So your objective is, by using rectifier, your objective is to obtain some average value for this AC signal, So here you have 230 volt transformer. Here you have 230 volt transformer. In India, 50 hertz is supply frequency. This sine wave having a 50 hertz. Frequency is equal to 1 upon time period. So here time is given. So f is equal to 1 upon t, time period, total frequency. So this is the input signal which is fed at here, and this input signal is step down here to your 12 volt in current experiment. When this 12 volt coming into means here in this experiment, then what happens? See, one time this become positive, this negative. For this half cycle, this become positive, this become negative for this half cycle. For another this half cycle, this end become negative and this end become positive. So here how now we are in position to explain the working of this rectifier, working of this rectifier. So when this terminal is positive, when this terminal is positive, this terminal of your transformer is positive and this terminal of your transformer is negative, then what happen? This diode is reverse bias, because this terminal is positive. When positive connected to cathode, your diode is reverse bias. When your positive signal connected to this diode anode, then this diode is forward bias. So current will flow in this direction, not in this direction, because here it get a open path. When this current will flow in this direction, when current flow in this direction, now when it come here, that this terminal, this diode is shorted. Because of short, here ideally no voltage drop across this. So whatever the voltage, the same voltage here. So positive voltage here. Because of this positive voltage, this diode is reverse bias. This diode is reverse bias. So this current will not follow this path. Instead, it enter to the your ammeter, which is connected here. Through this ammeter means current reach here. This current will not go in this side, because this multimeter connected in voltmeter arrangement. When a voltmeter is there, it offer a infinite resistance or large resistance. So current will not go in this direction, current will flow here in this term. So where current is entering, due to the convention, this end become positive, this end become positive, this end become positive. So this polarity become positive, this terminal of the your load is become positive. So current enter here and current should leave also to complete the circuit. So this is a positive value and this is a negative. So what about this? This already you know, this diode is in reverse bias. So here this negative and this positive, because of that reason cathode is connected to, if you one time you forget this also, but here cathode is connected with the negative. Because of that reason current is conducting through this diode. So your current conduction path is from here to here and then entering in the load resistance, and then it is entering to the your transformer negative. So it is coming from the positive of your transformer, secondary of your transformer, and it is following this path. The now path is completed. See once again the path, this is the your path, this path is completed now, this path is completed now. Your current is flowing from here and here. Just remember, your current is entering from here. So now half cycle is completed. Your current is positive in this direction. If you consider this as a positive direction, then your this half cycle is completed. Now come to the negative half cycle. When you come to the negative half cycle, this is a negative half cycle. When you implement this negative, means imply this negative half cycle on this capacitor, then what happen? See, when you apply this negative half cycle in this capacitor, then what happen? This transformer, then what happen? This end become now negative, this terminal becomes now negative, and this terminal become positive, this terminal become negative, and this terminal is positive. When this terminal is negative, then what happen? This diode is now reverse biased, this diode is now reverse biased. No current will flow through this, because it is acting as open path. Here is open path. Now your current is flowing where? Just this is negative, this path is blocked, and this is positive. So we consider a positive, we consider the positive in carry the current. So the diode, see what is the situation of this diode and this diode. When this terminal is positive, for negative half cycle here, for negative half cycle here, then this end is positive. So of course this diode is reverse bias, this diode is reverse bias, and you are finding a path, your current is finding a path here. Current will go here and enter in the same direction in your ammeter and in the same direction your means load. So your load will show same voltage what previously. So this is the beauty of your means rectifier. Previously it was bipolar, means positive half cycle, negative half cycle, but here for whole cycle you are getting means for only positive voltage, negative corresponding to this pulse is converted. Why this is because current entering from same direction, this is the direction of entering of the current, this is the direction of enter of current, because of that reason it is positive, because of that reason this cycle you are getting means in the same direction. Now what is the change? Here you were getting the 0 DC, here average value of the current was 0, but here not 0, here you are getting some DC value. By applying the same formula, here T by 2 is the time period, 1 upon T by 2 integration 0 to T by 2 Vm divided by 2 sin omega t. If you integrate that, then you will get the value of your average value as per this 2 Vm upon pi, this equation. So this was the working of your rectifier for both half, first half positive and second half negative. Now come to the drawback of this bridge rectifier. The drawback of this bridge rectifier is, here you are having some pulsating DC, here you are having some pulsating DC. Your objective is to remove this pulsating DC. So how you can remove? Scientists were observe, if we filter this pulsating by connecting a capacitor, then we can remove this pulsating DC which is appeared across this load without connection of capacitor across this. There is a many type of capacitor means filter. First one is simple C, L, RC, LC, RLC, all these can be useful for this. If you further remove the ripple factor, ripples are the DC component in your means output. With VDC you have some pulsating DC, that is your ripples, that is AC signal. AC signal in your output is called as ripples. So these are the ripples. So how your capacitor minimize this AC component at the output? When you connect a capacitor here, then what happen? When this voltage rise from 0 to this capacitor charge towards this maximum value V maximum. But when this output is dropped across the load, then your capacitor discharge through 0. But if your time constant of the circuit RC value is selected in such a way, this time period is this RC is very less than this RC is means time period of this time period of this pulsating DC is not much, so that your capacitor discharge completely, then you will get your capacitor discharge up to this point, again second pulse come and it charge the capacitor, and again means it is capacitor start discharging, in between another pulse is coming and charge the capacitor. So now you can see previously your pulsating was from here to here, now but connection of the capacitor it is from here to here only. So this is the beauty of your capacitor, which is connected across the load of your rectifier. Okay. So this is the procedure how your bridge rectifier perform, or how your bridge rectifier convert a AC signal into DC signal, and further remove the your pulsating DC or AC signal from the output. Now I will not go much detail about this. I will tell you only how to proceed, a small thing, how to proceed the experiment, how you can perform the experiment. First connect the circuit as per figure first. This is the experiment without this is the experiment of bridge rectifier without filter. Then connect a oscilloscope here at this point, here oscilloscope here, and one channel of oscilloscope here, CRO here, another channel here. So here we have here you can see, observe the input and output on the CRO oscilloscope. Another thing, now measure the AC current, analog current, varying current through the, and DC current, and VAC voltage and DC voltage. VAC voltage, generally your multimeter reading the RMS value, IRMS, VRMS, and when you place the knob in DC mode, it measures the DC voltage and DC current. So your you have to shift only here IAC RMS, here VDC VAC. Here you will not change this as a voltage. This here this ammeter is connected in line with your load and your transformer, not parallel, but your voltmeter is connected in parallel. So after reading all these things, you tabulate them in this two table. This is a without filter and this is a with filter. This is the without filter. Here in this table you list is IAC, IDC, VDC, VAC. So how IAC? Just change your ammeter knob, multimeter knob in AC mode, and in this you change your meter knob in DC mode. So by changing AC and DC you can measure both IAC and VDC. Note that you should not change the position of ammeter and voltmeter. One is reading IAC, IDC, another one is reading VDC, VAC. So this is the theoretical analysis. This is the theoretical analysis of your here you can compare VDC value which you are getting which you are getting from your multimeter, and this is the this is the theoretical value. VM is 12 volt, pi have 3.14 to multiply by 2. Then you calculate the VDC and you can compare the VDC measured by this equation, obtained by this equation, and VDC which is measured by your ammeter connected, voltmeter connected here. The difference, you definitely find a difference, which is because of your means low resistance of secondary of your transformer and resistance of your diode itself, on resistance of your diode. So here you will get the difference between whatever VDC you are measuring across the output by your voltmeter and what is calculated value of this, both will show different reading. Here IDC is equal to 2Im divided by pi, or IDC you can simply calculate from this relation, both result will be same. And Vrms is equal to Vm divided by root 2, and this is obtained by root of root 1 by t 0 to t I Im square sin omega t dt. That is the formula for Vrms and Irms. When you divide Vrms by BDC whole square and take the whole square and minus 1, you will get the ripple factor, and neta here written wrong, PDC divided by PAC multiplied by 100. This is a means efficiency. This is your theoretical efficiency 81.2. If you measure the VAC, IAC, means divide them IDC into means IDC, VDC, then you will get some difference in efficiency, that is the component drop in the component load resistance, drop in the secondary of the transformer and the diode, all these things. Now your second experiment, this was the experiment with without your filter. So for second experiment you have to follow the procedure, connect the circuit as per figure this, second figure, as per the figure this, and then again observe the input output in oscilloscope. You can now see this waveform at the output terminal. At the input terminal you can get this waveform, at input terminal you will get this waveform, but at output terminal you will get this waveform when you connect capacitor across the load RL. And again measure the AC, DC, means again measure the AC, DC, everything, fill the table to this table, then and one time you connect your means 100 microfarad across the RL, then you connect the 1000 microfarad across the RL and try to find the ripple component, variation in ripple component. Here with theoretical value of ripple factor, when you involve the capacitor, then you will get you have to use this formula 1 upon 4 root 3 FCRL. This formula came by analysis of this by using triangular wave, that is out of scope of this experiment. We will discuss means somewhere, it is discussed in many books in very nicely. So this is the from using this graph you can identify this formula. But practically in ripple factor you have to substitute, measure the Vrms value, means AC signal, DC signal, everything, and you can calculate the ripple factor root of measure value, and if you want to compare, you can compare that value. This is theoretical value which is you are getting from here. This is the theoretical value. This is also theoretical value. So if you substitute in this value, this experiment here, means your measured value, you will get the different ripple factor, different efficiency. That is the one method. And another way you can divide the means peak to peak AC signal to DC signal, that is another way of ripple factor. So hope you find this video helpful, and have a nice day. Thank you.